Okay. And yes, you'll be submitting today's thing on Canvas, but as explained in the document for Thursday exercise, blame Pope Gregory the 13th. Keeping track of time has been a very important thing, okay, for many cultures. If for no other reason, then you need to know when the seasons are going to change, and so you can do your planting and your harvesting, and making sure that you can keep enough time, keep track of time, so you know when the cold comes. There's many different types of calendars: solar calendars, lunisolar calendars, lunar calendars. The primary calendar that we use, and the calendar that's used as the civil calendar throughout most of the world, is the Gregorian calendar, which was introduced by Pope Gregory the 13th in 1582. It says so right here on the Wikipedia article. Right now, this is a replacement of the Julian calendar. All right. Now, the Julian calendar came into use before that, but I mean, just because this was introduced in 1582 doesn't mean necessarily that that was what was in use. For instance, if we go to the page on George Washington, okay, you'll note that there is an annotation on his birthday, which says that contemporaneous records, in other words, the records when he was alive, use the old style Julian calendar and annunciation style of enumerating his years. So his birth was recorded as February 11th, 1731. But after the British Calendar New Style Act of 1750, that was implemented, it altered the dating method. And so it ended up like creating an 11-day drift between record keeping. Now, the reason for this is that the Julian calendar, it drifted, and you can see that today in the Gregorian calendar is the 10th of February, but in the Julian calendar it'd be the 28th of January. It's kind of lagging behind, and the reason for this is that the Julian calendar has two types of years. You have a normal year and a leap year. Okay, and it follows a simple cycle of one leap year and 3 normal years and 1 leap year. Okay, and that means that your average year, that on average a year is 365 days long. However, 365 and a quarter long. But the actual solar year, in other words, the amount of time that it takes the Earth to rotate around the sun is actually a bit shorter than that. It's 365.24 days, slight difference. And the more years that go by, the greater this difference becomes. In other words, the Julian calendar gains a day every 120 years. Not big issue in year zero, around year zero, but anyway, it will be. It has been an issue since then. And because of that drift, you have issues. Now, many different calendars, by the way, do deal with this in a different way. The Hebrew calendar, being a lunisolar calendar, meaning that there's a certain number of months, what they do is that they insert an extra month, the 13th month, every so often, which is a bit, but that's to make sure, again, that the harvest seasons kind of and the holidays all line up at the appropriate time. I can't speak to other faiths, but I do know that that is something that other faiths do. So there is this issue with imperfection of keeping time, and so you've got leap years in some calendars, the Gregorian calendar. You've got leap months in others, and then also, just to mess with you, the length of a day is occasionally corrected by inserting a leap second into the coordinated universal time because of variations in the Earth rotation period. Yeah, you've probably heard something about, you might hear when there's this huge earthquake every so often that there's kind of how it affects the Earth rotation just a teeny bit, and that can kind of happen. So leap year is kind of it's just an interesting quirk of the fact that basically the rotation of the Earth Earth rotating around the sun and the physical spinning of the Earth, you know, in its day-night cycle doesn't precisely line up. That's basically what it comes down to. There's an interesting quirk of that. So what we're going to do today is we're going to create a date validation program. You can find it under modules on Canvas, although you don't need to. You can follow along because I'm about to broadcast it. But if you want to look at the PDF yourself, you go to Module 5, click the Thursday exercise, and when you're done with it, you'll want to upload your code here. You don't need to demo this, but this isn't the textbook, so I need you to submit what you have here. And I'll basically very quickly check it off after you've done this. If you're watching this later because you weren't here for the lecture, upload your code, and I'll eventually get around to checking it. So this is the PDF I wrote. This used to be a homework assignment, but it caused much wailing and gnashing of teeth. So I've made it its own assignment, own in-class exercise. It actually isn't too bad. It's just the logic can be very tough for for the first time you're introduced into if statements and else statements. And it's non-trivial. Don't worry if you feel like you're lost during this one, because this one is non-trivial for basically anybody of any kind of programming level. All right. So what we're going to do is that we're going to take a string, we're going to look at it, and we're going to test whether that given string is a valid date in the Gregorian calendar setting. Okay. It should output whether it's valid. If it's not valid, report why. So first off, let's talk about the kind of date formats we can expect. We're going to expect our user to input it. We'll assume that our user inputs it in this format: 2 digits for the month, followed by a slash, 2 digits for the day, followed by a slash, and 4 digits for the year. This is the typical US style of date. There are some other countries that do, I think, day, month, year, you know, but we're in America, so we are going to do the American way right now. Okay. So, and this also means that anything we get, any date that we see like April will be presented as 04, all right, 04. Don't worry, Python's able to handle that with the preceding 0. Okay, valid months are in the range of 1 to 12, right? 1 through 12 is their numbers. Also, September, April, June, November, each have 30 days, right? Some months have 30 days, some have 31 days. Right, so April 31st is not a valid date, right? Because we don't have, because there's no April 31st. There's just April 30th. Then it would be May. All other months but February have 31 days. February is unique. It has 28 days, except on a leap year, which has 29. And now here's the unfortunate fact where I have to reveal to you that a leap year is not the way it works. You think it works like the Julian calendar, because it's almost always certainly correct like that. Especially if and it has been correct like that, if you started school post 2000. A leap year is any year not divisible by 4 is not a leap year, right? If it's divisible by 4, it may be a leap year. It's not a guarantee. That's the kicker. All years divisible by 4 are not leap years. Most of them are. So a year divisible by 4 is a leap year, except that any year that's divisible by 100 is not a leap year, except for years that are divisible by 400. That is the way leap years work. It will never come. It won't come. This will not come up until the year 2100. It didn't come up in the year 2000 because that was a year divisible by 400. So it's not really, so for the most part saying, hey, a year divisible by 4 is a leap year. That's accurate in the vast majority of cases, except for certain dates. So for instance, 1644 is a leap year, right? Because 1600 is divisible by 4 and 44 is divisible by 4. So 1600 plus 44 is divisible by 4, it's a leap year. And it's not divisible by either 100, 400. So 1645 is not a leap year. 1600 is a leap year. It's divisible by 4 and 400. But 1700 is not a leap year. because it is divisible by 100, but not 400. All right. So now, generally we can, so basically, let's look through this. All of this program was reasonable up until the point we got to leap years. But leap years only occur in February. So what we're going to do, and what you should do when you see something like this, where it's like, except for this one case, I can do this, carve out that case. Don't obsess over it quite yet. Carve out your case and try to work on it, everything else but that thing, and have the specifics aside. In fact, it only meant work. In fact, you only have to worry about this on February 29th. You have to only check February 20. You only care about checking if it's leap year if somebody's saying, hey, it's February 29th. So the couple things we have to do here. First, we're going to be getting our input as a string. The first step we're going to want to do is slice up the string into its appropriate components, right? Now, to slice a string, we can use this operation over here. If you haven't seen it yet in your readings or the lecture videos, this is the way it works. It uses the index notation, and it uses the same kind of up to but not including notation that range used. So here is my name. So 0. Hold on one second. Annotate. I've got this fancy pen. I should use it. 0, 1, 2, 3, 4, 5, 6. All right. So 0 up to including 2 will give us my, well, capital MY, right? Because it goes up to but doesn't include that space. 3 to 6. So index 3 is the N, up to but not including index 6, which is E. So we'll give us NAM. If you want to go up until the end, you can just leave off the, after that colon, you can just leave off that slice. You'll want to get practice with these slices. They're very useful operations, and you should be getting practice at least in the readings. The other thing we're going to need to know how to do is converting your strings to integers, but we've already known how to do that. In Java, it's a bit more of a pain in the sense that it takes a bit longer. So what we're going to do is, so generally when this was a homework assignment, I'd basically say, hey, can you tell me if it's a date or not? Can you tell me if it handles non-leap year dates versus can it handle leap years dates? Okay. If you're interested in just how much, so, and just take this piece of advice. If you stop listening to this at any point, just listen to this. Okay. In the future, if you're ever supposed to deal with anything that has to deal with like time or timekeeping, don't bother. It's too much trouble. Leave it to the libraries that are already written. Don't try to only, like, seriously, import the built-in libraries that have been built into your programming language, because it is such a pain. Like again, dealing with leap seconds. And also like when you, and really that you can care about this when you care about the order in which things execute. Like Google has their own internal kind of way of keeping time so that things are executing in the right order. And it doesn't matter if it's not consistent with the outside world. What matters is that it's inconsistent with the inside world, the execution environment. So there's a video by Computer File that I thought was an excellent video on that topic. If you're so inclined to find out more about why keeping track of time is a bad idea, because time zones are arbitrary and they're a nightmare. Okay. All right. So the first thing we're going to want to do for this, I've created a Python file. And the first thing we're going to want to do for this is we're going to want to take in our input from the user, right? So what we're going to do is that I will need a input. Please enter /. dd/yy. And then I'll just do a colon, and then I'll do a colon, and then I'll do, yeah. And that should work. Actually, I'll do a colon/t. No, sorry, colon and a /n. So you put it on the next line. Okay. And then we'll take that in as a date. Now from this date, what we want to do is that we've got, we need to split this up in, we want to get the month, the day, and the year stored in separate variables, because otherwise it's going to be a pain, right? We want to go ahead and split that up into separate variables. All right. Now to do so, we want to use that slice operator. So I'll let you get to that in just a second to try it on your own. But if we're looking at month, day, and we need to keep track of it, we need to slice these specific indexes. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 characters long. So we want to use the slice notation to split it up into the appropriate subsections. Remember, the slice notation is like string or list, and it's your start point up to, but not including the end point, right? That's how we do slice notation. All right, so I will give you about 2 minutes to work on that one, and then I'll show you the answer, and then I'll move on to the next, to basically where we should, to kind of the top line kind of way of dealing with things. Okay. So to slice this, well, let's work on the month first. Okay. What we're going to do to slice this is we take our date and we want to get these two characters. So we want to start at index 0, but go up to, but not include 2. That's how we do that. As far as the day, we start at index 3, go up to, but not include 5. And then for year, we actually get to cheat a bit because what we can do is we can leave the end off to say I'd like to go all the way to the end. So 6 to the end. 8. 6 to the end, like that. Let's go ahead and print it out. Print day, month, year, or rather month, day, year. Please enter month, day, year. And now we'll do 11, 11, 11, 11, 11. Sorry, 11. Let's do this a bit, make it a bit easier distinct. So there we were able to split it successfully. Now, one last thing we have to do, because we're going to be working with numbers for the most part, right? Is that we want to actually turn these into numbers. I didn't mention to do that, but now's a good time to do that. So just throw what we did into int statements to convert all the strings into ints. If that makes sense to everybody. Because we're going to be working with numbers, right? It's easier to compare numbers to strings. Sorry, numbers rather than strings. And considering we're going to be checking for divisibility. Okay, so now 0, 1, 0, 2. So notice that it will handle these preceding zeros, by the way. 0, 2, 0, 4, 2004. And it gives me month 2, day 4, and year 2004. Okay. So our next step is basically that we need to start like doing our validation. And there's one very easy validation we can do, right? So the year being valid is dependent on it being February 29th. So we're not going to worry about what year it is and validating the year unless we're in February 29th, okay? Now, as far as the day, figuring out how many days we have is dependent on what month we are dealing with. So we'll leave that till we're dealing with months. And months, we just got to make sure it's in the proper range, right? So you can go ahead and categorize things, right? Months fall into 3 separate categories in terms of date validation, right? We have the days, which have 30 days. We have the months with 30 days. We have the months with 31 days, and we have the months with 29 days, or 28 or 29 days, right? So we have 30 days, 31 days, or February. So let's go ahead and kind of like just put in the shell for that code to be completed. So our first category, 31 days. Let's do that first. Okay. And I'll do this first one, and then I'll rely on you to do the others. Okay. So September, April, June, and November each have 30 days. So what we need to do is if month equals, so January has 31 days, or month equal, so not February, but March has 31 days, or 3. So common mistake, by the way, when you're just starting out is to do this. If month equal 1 or 3, or April, May, 5, June, right, and so on and so forth. But this doesn't do what you want. You got to be specific, because if it's by itself, it's saying, oh, it's a positive value. That means it's a truth value. So values in Python have truthiness and falsiness, right? Anything that, so you can use any kind of value in place of a Boolean if you needed to. This is a holdover from C, but basically anything that is non-zero is considered true. So here it's saying if month is 1 or true, in which case it would be true. So what we need to do is we need to be specific, which is if month is equal to, or month is equal to, so if month is equal to 3 or 5, so June is 6 or 7, July, or month is equal to 8, which is August. Or September, so September has 30, or month is equal to 10, or month is equal to 12. All right, so we should have 12 minus 5, 7 values. Month, so 1, 3, 5, 7, 8, 10, and 12. So there. Now what I'm going to do here is I'm going to go ahead and put pass over here. Now pass is not ever any, yes.
Wait, are you checking for 31 days?
Yes.
But wasn't like June or
They have 30 days. They have 30 days. June.
so why
Did I include June? I included July. May is 5. Yeah, I was counting off. I was counting off mentally, like going through them in order. There's a lot, you know. So here we go. We've got. Okay, so right over here, what I did is I put in a statement called pass. Now, what pass does is that says, hey, I'm a placeholder. If you see me, it's because somebody didn't finish this code. But the reason we have this pass here is so that it's syntactically correct, so that we have something, to kind of check off. So that if I don't have the pass, if I try to do another if statement over here, I'll get an indentation error of something. Alternatively, I could just leave out the pass and put print 31 days for debugging purposes. So what you'll want to do yourself now is you will want to try to do the 30 days. And that should be something along the lines of elif, and then your conditions in here, which is short for else if, as well as February. Okay, so go ahead and take a couple minutes to work on that. You could make them ifs rather than elifs if you want to, but a good practice to, since they're mutually exclusive, to make them else ifs. Mm-hmm. No, it will automatically convert that. So the int function automatically converts anything with preceding zeros. So for instance, if I have 0, 4, it won't let me do that. 0, 4, it's not going to let me do that. But if I convert from like 0, 0, like this, it removes those preceding zeros. So it's not going to be an issue. Would add another step, which would not be fun, but that's okay. Sorry?
Does it matter if they're like?
No, the order doesn't matter in which you put your months. I could have done 1, 3, 5. I could have also done 1, 5, 2, 1, 5, 3. Or 5, 1, 3. 3, 5, 1. Mhm.
If I wanted to check if, like, say, get a Boolean statement, if the month I put in like 13, for instance, would I have to put another if statement? Because if it's any of these.
Yeah,
then go through.
they're gonna be nested, yes.
So do I put a third if statement like here, and if none of these, then month valid false?
You'll see, I'll show you. I'm gonna simplify it once you see what I've done. Okay. What I'm doing is an if else statement. So that's why I'm doing the if, elif, because I'm gonna do an else statement on the end for none of the above. Yeah, I'm doing the elif for a reason here. All right. So for February, it's fairly simple. If month is equal to 2, right? And so for now, all we need is all the other remaining dates, which are April, or month is equal to, what was it, May? Not May, June. So April, June, September, I believe, and November. So month is equal to 9, or month is equal to 11. So now we've got this split up like this. What in the world is going on with these double spaces? All right. Okay, that's very weird. Okay, so what I've got over here, I'll put in another print statement under each of these so that they will compile. Print 30 days. Print 20. Print February. And now for the other thing that we can do, since we've got these all as else ifs, right? So the if, we're going to check if it's 31, if it's in the 31-day category. If it's not in the 31-day category, we're going to check if it's in the 30-day category. If it's not in the 30-day category, we're going to check if it's in February. That's what else if means. It will go into the first slot that it sees that's appropriate. They're all kind of dependent on each other. And finally, else. Else, what's the else? The else is it isn't a valid date. It isn't a valid month. Invalid month. So we'll go ahead and move this up here. So if I try April 15th, 2022, we're gonna get directed to the 30-day if statement. All right, if I try the 14th, if I try 14, the 14th month, let's call it January or something like that. So January 14th. So January, actually 90th, 1482. we're going to get back that it is an invalid month because there is no 14th month in the Gregorian calendar. Make sense? Okay. So right now we figured out how to kind of do our date validation there, or rather a month validation. Now we've got three separate cases to deal with, which is that we want to check, which is that we're either in a 31-day month, a 30-day month, or it's February. So in each of these, we need to check. So let's try each of these one at a time. In order to validate the day for 30-day, 1-day months, we don't really care what year it is, right? Don't care what year it is. If it's January, it's going to be a valid year no matter what. So, in fact, any year is pretty much a valid year. What we need to check for is is whether or not the day is valid, right? So if this is a 31-day, we need to put in another if statement that checks if this date is valid. If the date is in range, then if the day is in range, then the entire date is valid. If the day is out of range, then it's invalid. So go ahead and take 5 minutes to try that for 30 days, 31 days, 30 days, and if you can, the non-leap year Februaries, right? In other words, all the dates for February that are 1 to 28, because day 29 in February is what's the special case. So go ahead and take 5 minutes for that on your own. All right, so now it's time for me to gush about one of those things I love about Python. All right, so for it to be 31, so for a date to be valid in January or March or something, we have to write an if statement that gives us the range, that does the appropriate range. So if, so in other programming languages, we might have to write something like this. If day is less than or equal to 0, or if its day is greater than 31, print invalid date or invalid day, right? If it's out of range of that, right? So if it's more than 31 or if it's 0 or less. And you have to kind of, if you have an upper or lower limit, you'd have to split it up with like 2 statements like this. Not so in Python. Python's awesome. I can totally write this instead. And I'm going to just simply instead turn it into a statement for valid day. Okay. If one day and that works in Python, where you can make a compound state, a compound comparison statement like this, right? So long as day is between 1 and 31, at least unless I'm horribly mistaken. We'll go ahead and test to make sure that I'm not horribly mistaken. I remember doing it last semester, but I mean, and the semester before that, and the semester before that, but always good to make sure. So if month, so basically let's go with January 32nd. Says, hey, invalid day. Now let's try January 05, 1900. And that's a valid day. So this expression works, which is what I love, one of those little quirks of Python. Those little just quality of life benefits that just make working in Python such a pleasure. Okay. Next, let's take a look at and so for this one, it's not that hard to take this and do that for the other 2 blocks. Right? It's going to be, if it's got to be 1 to 30 inclusive, then we just change that to 1 to 30. And then for February, what we're going to do is we're going to do that one. We're going to work with February just a little bit differently because we have a leap year that we have the leap year question. So we're going to, so no matter whether or not it's a leap year, any date in February that's 1 to 28 is valid. Anything above 30 and above is invalid. It's only on day 29 that we have an issue. If day equals 29. That makes sense? We only care about it being, so we only care about it being 29 here. Now, what I'm going to do before I continue is I'm going to go back up here and I'm going to write a function at the very top so that as not to clutter up my code with a horrible hodgepodge of if else statements that we're going to be writing right now. I'm going to write a function that does one thing and one thing only. Tells me if whether a given year is a leap year. Def is leap year. And I like to name my functions that return true or false, like is something, because that tells me if whether it gives me true or false. Is it a leap year? True or false? So it will take in a year. Is leap year will take in a year, and it's gonna figure out whether it's a leap year. So what I'm going to do, and first off, what I'm going to do is that I'm going to assume that it is, for right now, I'll just simply return true to assume everything's a leap year until otherwise proven. Return true, which isn't a great strategy for right now, but it will work for, which isn't the optimal strategy at the moment. It's not correct, but it'll work for right now. So let's go back to the leap year rules because we need to really revisit those before we can take a stab at it, okay? A leap year is not divisible by 4. Sorry, a leap year not divisible by 4 is a normal year. A year divisible by 4 is a leap year except when it's divisible by 100, except if it's divisible by 400. If we go over to the Wikipedia page, they have a bit of a more thorough definition, or a more, not thorough, but like, yeah, these extra leap years occur in each year for each year, which is an integer multiple of 4, except for years divisible by 100, but not 400. Okay, not so much. It's the same thing. Unfortunately, this article has algorithm on it, and we've got a flow chart. That's useful. So given a year, if it's divisible by 4, if it's not divisible by 4, it's a common year. If it's divisible by 100, if it's evenly divisible by 100, if not, it's a leap year. And then whether it's divisible by 400 or not, yes or no, depends on whether it's a leap year or not a leap year. So regardless of what we do, of anything we do, we should probably start by asking, hey, is it divisible by 4? There's a couple of different ways to do this. But the first thing we should ask, if it's divisible by 4. If it's not divisible by 4, then it's not a leap year. So go ahead and try that on your own. But how do we tell if something is divisible by something in a programming language? Yes. That's exactly correct. You use the modulo operator. And what you do, so for instance, to check if a number is divisible by 2, I would ask if num mod 2 equals 0. In other words, if I divided by number by 2 and I got the remainder of 0, that's what I'm asking. If I divide this number by 2, am I getting the remainder 0, right? Because anything divisible by 2 gives me a remainder of 0. So that's how you tell if something's divisible by 2. If it's divisible by 10, you just simply say, hey, if I divide by 10 and remember, because modulo gives you the remainder. So if this number is divisible by 10, right? Sorry, if this number is divisible by 10, great. So here we want to write just a basic statement starting out, is it divisible by 4? So give you a minute to do that. All right. In this case, we're going to just ask, hey, if year mod 400, so not 400, well, we could start with 400, but right now we're going to, that's another strategy of going, but if year mod 4 equals 0, then we're going to want to do stuff, which I'll put the pass in. Otherwise, return false, right? It's not divisible by 4. Now leap year. Another way I could write that is that I could just simply do, hey, if year is something other than this, and then I could continue on. Then I could continue on from here. Does that make sense? If year mod 4 is something other than 0, right? So now at this point, if I'm at this line, I know it's a leap year candidate, right? So it's at this point, I know it's divisible by 4. Either way works fine for the way we want to arrange this. So now I've got to ask myself, I've got this thing that's possibly a leap year. If it's divisible by 100, then it may not be a leap year, but otherwise it's definitely a leap year. So if year divisible by 100 is not equal to 0, or year divisible by, actually I do it like this. Year divisible by 100 is 0. So if it's divisible by 100, it might be a leap year. But if it's not divisible by 100, at that point, we know it is definitely a leap year because we just checked if it's divisible by 4. It's divisible by 4, but not 100. And because I'm mixing, but I'm starting to get disorganized. So I definitely want to make sure I keep consistency with however I'm doing it. So I'm going to rewrite it just to make sure it's consistent. Otherwise, we're going to get our very windy logic. So if the year is divisible by 4, else now we can ask, okay, if the year is divisible by 4 and all right, stay safe. If the year is divisible by 100, so if we're in this block right here, we know it's divisible by, divisible by 4. So if it's divisible by 100, we need to check something else. But otherwise, if it's divisible by 4, but not by 100, return true. Okay. And now finally, if it's divisible by 100, it's not a leap year unless it's divisible by 400 as well, right? So for instance, actually, hold on. Sorry, if it's divisible by 100, right? They're evenly divisible by 400. If it's not divisible by 400, if it's evenly divisible by 400, it's a leap year. So if year divisible by 400, right? If it's divisible by 400, it's a leap year no matter what, right? All right, divisible by 4, divisible by 100, divisible by 400. Else, now certainly there are possibly other ways to do this. There are multiple ways to do this, but I like this way, or at least to start with. Another way we could do it is we can do a compound statement. If year mod 4 equals 0 and year mod let's see, what is it? And year, let's see, year mod 100 not equal to 0, or, and you could basically do this in one line with a bunch of parentheses. So if year is divisible by 4 and year divided by 100 is not equal to 0, or year divided by 100 equals 0, and year 400 equals to 0, which, as you can see, got a bit long and a bit excessive, right? So if it's divisible by 4 and it's not divisible by 100, or it is divisible by 100 and by 400, then it's a leap year. So that's another, then we could return true if true, otherwise return false, or we could skip that entirely and we could just simply say, hey, just return the result of the statement. That's one possibility. Okay, but now we've got this function, we should probably try it. So now what we need to do with this function is that we scroll all the way down to here. And we say, hey, if month is February, if day is 29, and actually what I'll do is, because I want to be more specific, if the day is 29, I will say if is leap year. So that's how we invoke our function here, by basically calling the function we just wrote. If our year is a leap year, print valid day. But if it's not a leap year, we need to give a reason to why this is an invalid date, in which case we'll say, and I'll go ahead and steal this statement that I had previously written. I will say, not a leap year, like that. Let's take out the spacing over here and see what we've got over here. So we've got ourselves this is leap year function, which we've got to test. So what we're going to do is we're going to test it by saying, hey, February 29th, that's the only way we're going to ever test if it's a leap year. 1904 should be a leap year. Let's run again. February 29th, 1905, not a leap year. Makes sense. February 29th, and now we need to try these ones. 1900 is not a leap year. And let's see, is that correct according to our flow chart? If it's evenly divisible by 400, so it says any divisible by year divisible by 400 is not a leap year, except if it's also divisible by 400. So 100, so 1900 is not a leap year. But the year 2000 is 02, 29, 2000 is a valid day. Right? So this is what I meant when I said nobody knows how leap years work last week, because this is a lot of logic. There's a lot of rules. It's not a leap year Sorry, it's a leap year every 4 years, except if it's a century, but not every 4 centuries. And this is also what I mean by it's non-trivial. Trying to keep 3 if-else statements that are kind of dependent on each other like that are a bit tricky. I mean, there's some fancy math we could probably do with the fact that 400 and 100, that 400 is divisible by 4 and 100. But it's easy to kind of attack this problem like this. Now, again, leap years are tricky. But it looks like we've went ahead and finished our date validator, and that's not a trick question. We have finished our date validator here. All right. Where we print out our 30-day, our 31 days, our 30 days, and then February is the only real issue. All right. So that is what is available for today. But before I let you go, because it is still a bit early, before I let you go, what I want to just check is under the modules, I believe I still have to release quiz 3 because quiz 4 hasn't, no quiz 3 yet, I don't think. I think I released quiz 3 under module 6. Yep. Okay. Yep. So still the only upcoming quiz is quiz 2. I'll release quiz 3 next week. Again, be sure to do the quiz on time. Once we're done with the for loops exercise, we're going to do a bit of a easier exercise with something I took from Harvard CS 50 class, where basically you can choose how comfortable you are with the material. So using while loops and either figuring out how much cash you need, how much change you need to, or what's the best way to make change, or credit card validation, depending on your desire. Once we get to module 7, kind of everything is going to kind of come together. We're going to talk about file reading in module 7. And at that point, we'll work on the Hurricane tracker program, which will be awesome because that's kind of the big program you can kind of show other people and say, hey, look what I can do, because it's pretty effective at what it can do. All right, so with that, class is dismissed. What you want to do is you want to upload that code you typed up to Canvas, and I'll just simply take a glance at it and check it off.
What's the assignment called on Canvas?
Hold on one second. So my else was what?
It was like indented a little further, like each.
Yeah. My else was indented like this.
I don't know how to get it to do that without.
You have to. Shift tab. Mhm.
Do I do the same thing for the
Yep.
return trip?
Yeah, you want to do shift tab to manipulate those.
I'm gonna have to like rewatch this video,
Mhm.
but do you know how I would make this like multiple, like with an XML one?
You'd have to have a nested loop, and then your print statement, you'll want to use the optional parts of the print statement, the end and the separator, the end specifically. So if you do print, then what you want to print, and then comma, sep equals, and then you can print it. You can just say, I don't want the print statement to end as a space.
I have a question about the if and else. So if they're kind of essentially the same thing, why is there 2 different statements? Like
Else is short for else. Elif is short for else.
Okay.
So else ifs are basically one block of code. Only one of them can fire. That's what you use if, elif, else for.
Okay.
You only want one of these options to fire. The other one, if statements on the other hand, if you just use if, multiple ones can fire. A classic example of this is whether is like writing a program to determine what letter grade somebody has, right? Because if you write, if your grade is greater than 90, if a grader is greater than and then a 80, if a grade is greater than a 70, ABC.
Yeah.
If you pass in a grade like that, it will give you, if you pass in a 97, it will say ABC.
Okay, because it
But-
covers all of those.
Right. On the other hand, if you do, AB, sorry, I've got people asking me if I can scroll down on the code. On the other hand, if you do else if, the first one that's true will fire.
Okay. So if the first if is correct, then it'll just ignore the
Yes.
other else. Okay. And a question for the quiz, what chapters is it covering?
Just through turtles and for loops.
Okay. Thank you very much. Have a nice day.
I, sorry, I was kind of happened to catch up last moment. So I had a couple mistakes. So do I need to fix it or I just submit it right away?
You can submit it, but
I don't understand.
your main issue is this. If one is less than or equal to day, if one is less than or equal to day, less than or equal to 31. I mean, that was the issue there. Again, you'll be able to rewatch over here. Else is leap year. It's not is. It's one state. Yeah.
That should be good.
Yep, that should be fine.
Thank you.
I just copy and pasted the whole code to text box.
No, that'll be fine.
It'll be fine.
That'll be fine. Yeah, that's fine.
Okay.
I'm mainly just checking to make sure that people were paying attention in class and turned in something that resembled what we did in class.
Yeah, okay.
No, as opposed to just turning in a blank file or something like that. That's what, basically, that's what I'm checking out.
Professor, I still don't have my laptop until tomorrow. What should I do as far as turning the assignment in for today?
Turn it in when you get the chance.
Okay, so tomorrow. All right.
Yep. All right. Mhm. Hey,
Yeah, it's still not.
all right, let's go ahead and take a look and fix this. Okay. So,
I gotta test it. I gotta run through.
oh, I'm sorry. I wouldn't worry about it too much, but what's not, okay. So your outer indent area on line 8. So if what is with that? Okay. It's just if your indentation's kind of just messed up weird. I don't know why. On line 8 it says, and then I bet you bad input on line 37. Okay, much better. Yeah, so
How do you know what to do with the indents? Is it
you just got to be careful with them.
Mm.
You got to be careful as you're doing them. Okay.
Thank you so much.
Yes, just copy paste that into the appropriate spot.
Thank you so much for that.
No problem. Stop share.